Hello dear students, in the previous video we have gone through some demonstrations on resonance in tuning fork, pendulums and air column. Now in this video our objective will be characteristics of sound, objective and subjective nature, loudness and intensity, factors affecting loudness, pitch and frequency, quality and waveform and comparison between music and noise. So let us continue. So let us start today's session with the topic characteristics of sound. Okay, characteristics of sound. So here we are going to read the three characteristics of sound. That is, first one is your loudness, second one pitch, other name of pitch is shrillness, third one is quality, which is also called timbre. Now what is the meaning of characteristics of sound? What is the need of learning all these three terms? Okay, it helps in differentiating two sounds from one another. So we need to know more about these three in order to differentiate two sounds from one another. Okay, so let us read about loudness. What do you mean by loudness? Loud sound can be differentiated from a faint sound, both having same pitch and from the same instrument. For example, from the same instrument two sounds are produced. How can you differentiate them? We can differentiate with the help of the following factors. Okay, now let us learn the factors which are responsible or which are affecting loudness. First one is your amplitude. Greater the amplitude, greater will be the loudness. Okay, so here the relation is loudness is directly proportional to the square of the amplitude. That means if amplitude will become 2 times, loudness will become 4 times. Okay, so I'll show you in the diagram. Okay, you see, this is here one wave you can see, and here one wave you can see. Now this is the amplitude for this wave, and this is the amplitude for this wave. Okay, now see the two diagrams and tell me in which case the amplitude is more, children. In this case the amplitude is more. So this will be considered as loud sound and this will be considered as soft or faint sound. Okay, so out of this, if we'll compare these two diagrams, then this will, let us A and this one be B. So B will be more louder than A. Okay, so in terms of amplitude you can find the loudness of the sound. Next one is your distance. Closer the source, louder is the sound, and the relation is given as loudness is inversely related to the square of the distance. Okay, if the person is very near to the source, definitely the loudness will be more, and slowly if the distance increases, then what will happen to the loudness? Loudness will decrease. Yes, distance increase, loudness will decrease, because they are related inversely. Okay, now third one, surface area. Larger the surface area of the vibrating body, louder is the sound. If the surface area is more, sound will be louder. Why? Because more surface area means it carries greater amount of energy. That's why you might have seen in temples and schools, bells of larger size are used. For what purpose? So that they can carry greater amount of energy, due to which the amplitude will be more and hence the loudness will be more. Okay. Next factor is density. More is the density, more is the loudness. Okay, more is the density, more is the loudness. Why? Because if more is the density, then the number of particles present will be more, and if number of particles will be more, then we know that sound needs particles. Okay, medium for propagation. So we can hear louder sound. Okay, next, resonant bodies. Presence of resonating bodies near a vibrating body can produce loud sound. Yes or no? If a resonating body is present near a vibrating body, then we will able to hear a loud sound with the by what factor? This one, resonance. You know about resonance. If you want to know again about resonance, you can refer to the previous videos. Now, what are the unit of loudness? Loudness has the unit called phon or decibel. In the short form, it can be written as small d and capital B. Okay, so now you might have, loudness will differ from person to person. Okay, for example, if a particular sound is very soothing for me, it may be loud for older person. Okay, it may be louder for older person. So it differs from person to person. That's why this is called as subjective in nature. Subjective means it will differ person to person. It will differ person to person. Differs. Okay, now it is a non-measurable quantity. Since it is differing from person to person, so you cannot measure it. We will not get one accurate value for this loudness. Okay, so non-measurable quantity. Non-measurable quantity. Okay, so for this we have to learn about intensity. Now what is the purpose of intensity? Intensity is nothing but the amount of sound energy passing per second through an unit area. See, according to the definition, the relation is I, which is called intensity, is equal to E by T into A. E is your energy, T is your time, and A is your area. Okay, so now you see what is the unit of energy, children? It is intensity is directly related to energy and inversely related to area. You can see from this relation. So now, what is the unit of energy, children? Energy unit is joule. What is the unit of time? It is second. And what is the unit of area? Meter square. So now, joule by second into 1 by meter square. What is the unit of joule by second? What we call to that? We call it as power, and the unit is watt. Watt by meter square. Or you can write, this one you can write, this can be written as W per meter square or Wm minus 2. Okay, so intensity, you can calculate the amount of energy passing per second through an unit area by this unit. Okay, so greater the intensity, what will happen to the sound? The sound will be louder. Greater the intensity means more amount of energy is carried, so the sound will be louder. Okay, here I have mentioned some level of sound. It is found out, and here it is mentioned. For example, jet at takeoff, it is 140 decibel, vacuum cleaner 60 decibel, soft whisper 30 decibel, dropping pin 0 decibel. So dropping pin is the minimum audible sound. Dropping pin is the minimum audible sound. Okay, so these all are mentioned in terms of the unit called decibel, but this all value will differ from person to person. That's why I told you that loudness is subjective in nature. Okay, so what is the purpose of, since it is non-measurable quantity, so we have to find one measurable quantity for loudness. Now what is the purpose of finding measurable quantity? Because if the value will differ from person to person, then it is very difficult to find out the accurate value. Okay, so for that we are learning more about intensity and amplitude. With the help of this intensity and amplitude, you can measure loudness. Okay, so 0 decibel, which is the minimum audible sound, if you want to write in terms of intensity, the value is given 10 to the power minus 12 watt per meter square. 10 to the power minus 12 watt per meter square. So this is the value in terms of your amplitude. We have find in terms of amplitude, and here in terms of intensity. Okay, because the watt per meter square is the unit of intensity. Okay, so loudness can be loudness of two sounds can be differentiated in terms of your amplitude. Okay, and also you can differentiate them with the help of intensity. So can we say that intensity is a measurable quantity? Yes, intensity is a measurable quantity. Intensity is a measurable quantity. Okay, now our next topic is pitch and frequency. Okay, pitch and frequency. What is the other name of pitch, children? As I told you, it's nothing but your shrillness. Now what is the purpose of pitch? Okay, knowing about pitch. With the help of pitch, you can differentiate, or two sounds can be distinguished if they have same loudness. Okay, just now we have finished loudness, but think for a while that if two sounds are having same loudness, now how can you differentiate them? We can differentiate with the help of pitch. Now pitch depends on frequency. Pitch depends on frequency. So for example, here also you can find out that pitch is a subjective. pitch is subjective in nature, that is, it will vary from person to person. You cannot measure it. It's a non-measurable quantity, whereas frequency is a measurable quantity. You can measure or you can count. Okay, that means frequency is nothing but your number of vibration, so you can count. So here it is subjective and this is your objective. Frequency is your objective quantity. Okay, so now more frequency means more pitch, and if more pitch means the sound will be shriller. Less frequency means low pitch, and low pitch means the sound will be called as grave sound. See, you can understand this with the help of this 2 displacement time graph. Okay, waves of 2, I have shown you 2 graphs here. This is displacement time graph. So in the first graph you can see that if this is considered as one time period, you can see we are getting one wave. Okay, we are getting one cycle or one wave. Okay, in this case you can see same time period I am giving as in the case of first. So here how many waves formation is taking place? This is 1, till here it is 1, and this is 2. So here the frequency will be 1 and here the frequency will be 2. So now we can say that which diagram will have more pitch. So this one will have more pitch, this one will have less pitch. Since here frequency is more, so this will be of high pitch and the sound will be shriller in this case. Here frequency more, so high pitch and shrill sound. Okay, here what happened? Frequency less, so low pitch and grave sound. That's why we can differentiate the sound of men and women. Okay, whose sound is more shriller, children? Women's sound are more shriller than men. Okay, because of this number of vibration or frequency. Now our next topic is quality and waveform. The other name of quality is timbre. Now what is the purpose of knowing about quality? Okay, for example, if 2 sounds are given to you having same loudness and having same pitch, then how can you differentiate? Okay, in the first case we have learned about loudness, in the second case we have learned about pitch, but now in the third case, if 2 sounds are given, those who are having same loudness and same pitch, then how can you differentiate? And here we need to remember one thing, that those 2 sounds will be from different source or from different instrument. Okay, so they can be differentiated with the help of waveform. Now what is the meaning of waveform? How the formation of wave takes place in both the cases. For example, this one A is nothing but the waveform of tunic fork. This B diagram is nothing but the waveform of piano. So you can differentiate, or by seeing only you can differentiate very clearly what are the waveforms of these 2 instruments. Here you can see a single note, okay, or pure note. But in this case you will see that the vibrations are combined, more than one vibrations are combined. So with the help of waveform, or how the formation of wave takes place with the combination of vibration, you can find out the quality of the sound. So here again, quality is your subjective in nature. And what about waveform, children? Waveform is objective in nature. Similarly, pitch is subjective and frequency is objective in nature. Okay. So now let us come to our last topic of this video, comparison between the music and noise. Okay, so here I made one table which shows you very clearly the comparison between music and noise. So musics are regular, noise irregular. Music, they are smooth, here it is harsh. Okay, so they are periodic in nature, and here noise are non-periodic in nature. They are pleasant, music are pleasant, noise are unpleasant. And in case of music, the sound level is in between 10 decibel to 30 decibel. But in case of noise, the sound level is above 120 decibel. If it is it's above 120 decibel, then it's considered as noise. So I can show you all these features in these 2 diagrams. Okay, how can we differentiate with between music and noise? So here is your waveforms of a music and a noise. So here you can see very clearly this one is a waveform of a music, or we can say that the displacement time graph of a music. This one is the waveform or displacement time graph of a noise. So here you can see that it's pure note. Okay, here it's a pure note. Okay, there is a no increase or decrease in the frequency and amplitude, or here we don't have the combination of various vibration, but here you can see that there is a decrease and increase in the amplitude and frequency, and here very clearly you can see that the combinations of various vibrations. Okay, so this is considered as the waveform of music. This is nothing but your noise. Here you can see very clearly it is periodic, whereas here non-periodic. Okay, so just go through the differentiation and try to learn with the help of this diagram, because sometimes diagram is also asked, or the displacement time graph is also asked in the exam.